We're solving problem 2 from the 2025 AIME2. Find the sum of all positive integers n such that n+2 divides the product 3 times n+3 times n² plus 9. So, in order for this to happen, and we want to find the sum with this basically fancy z over here, we need this to be true. So first step we can do is pretty interesting one nonetheless, because it requires some amount of insight because this is not something you typically do. This becomes equals 3 and plus. We know that we have an n+2 here, right? But we have n+3 n² plus 9. However, we can cleverly see that 3 is equal to 2 plus 1, so that we do n+2 plus 1, n² plus 9 over n+2. Okay, now this becomes 3 times n+2 n² plus 9 plus 3 n² plus 9 over n+2. Now we can just cancel out the n+2 on this side, so we get 3 n² plus 9 plus 3 n² plus 9 over n+2. Having trouble drawing the symbol there, but now we can even further complicate this. So what we can do is basically all of this we put it back under the n+2 to get 3 n² minus 4 plus 13 over n+2, and this property remains the same. Then this right here becomes 3 n+2 and minus 2 using difference of squares, and then we still have that 13 in the parentheses left over, so we just sum a 13 times 3, or 39, over n+2. Once again, the n+2 cancels, so we have 3 and minus 2 plus 39 over n+2. So we know that this n+2 has to be a positive integer, and we basically can just start listing out factors of 39 because we want the sum of the working factors. So 39 has 1, 3, 13, and 39 as factors. This results in n having, you have to subtract 2 from each of these, so we have -1, 1, 11, and 37. We know that we can't have negatives because it has to be a positive integer, so we have 11, 1, 11, and 37, so we want to find the sum, which is going to be 49. I don't know why I drew a box around that, but sum is going to be 49, and that is our answer for this problem.